Hello fellas, welcome to the last video of week 5. We're just going to do a couple of problems on the law of cosines, and we're going to look at another area equation that's going to be helpful. But let's get started. Let's look at this first word problem. In a softball game, a batter hits the ball to dead center field. The center fielder throws the ball to third base. The distance from center field to home plate is 240 feet, and the distance between the bases is 60. How far did the center fielder throw the ball? So in this particular problem, here's home plate. Let's set up a triangle, 240 feet to dead center field. Here's third base, so here's the distance between this. So you got 60 feet between home plate and third base. We hit the ball dead center, 240, and so we're looking for D here. Okay, and because it's dead center, it means that we're going to split the diamond in half, and so that's going to be a 45-degree angle. This is a situation where we have a side here, an angle here, and a side. So this is side, angle, side. So we would use the law of cosines. We'd have a squared equals b squared plus c squared minus 2bc cosine of a. And so in this particular problem, this a side is the distance d that we're looking for. Okay? So if we look at that, we got d squared is equal to 60 squared. Again, we're plugging in for the two different sides. 240 is side C, and cosine of 45 is the angle included. Okay? Again, it's pretty much a straightforward plug-in, taking the square root of that number, and if we do that, we get a distance of 202.1 feet. In other words, the center fielder had to throw the ball 202.1 feet from her position where she caught the ball to third base. Okay, the toughest part about this problem, fellas, is setting up the diagram. And once we have the diagram set up, it becomes quite clear that we're going to use the law of cosines because side, angle, side, and then it's simply a matter of plugging in and solving. Okay, we're also going to mix them up a little bit. We're going to have law of sines, law of cosines together. But again, if you can identify the situation, side, angle, side, 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 you'll know exactly which formula to use. Ship travels 40 miles due east, then changes direction. When the ship has traveled 30 miles at this heading, it is 56 miles from its point of departure. Describe the change in direction. Again, the most challenging part of this is to get the diagram right. So here's what it looks like. I started here. I traveled 40 miles due east, so I'm traveling 40 miles in this direction. All of a sudden, I change my direction, and I'm going to travel 30 miles in that direction. When all is said and done, I'm going to be 56 miles away from where I started. Okay, so now I'm given three sides of that triangle. And I want to know about the change in direction. The change in direction is going to be this angle B. This is what is going to describe how I change my path here. Okay, so basically this is a side, side, side problem and looking for angle B. Okay, so again, that's the law of cosines. I set it up like that. And now I solve this for cosine of b by bringing these other terms to the other side. Done this before. We plug in, we get negative 0.265 inverse cosine or second cosine. And so we get 105.37 degrees. And so that basically means that our bearing changed 15.37 degrees east of north. And so what that means is if I'm heading in this direction originally, that's supposed to be due east. Here's north. Here's north, and then I'm going to come and I'm going to go east of that direction. So I'm going to come off. Whoops. I'm going to come off 15 degrees and head that way. Okay. So that's where the 15.37 east of north comes from. All right. Heron's formula, area formula. Again, this is another formula for area of a triangle. If it's given with sides, if I know the three sides, A, B, and C. Remember when we used the area in one of 2 videos ago, we had an angle involved. This situation, we're not using an angle. We're going to use this value S. S is going to be equal to the sum of the 3 sides divided by 2, and then I'm just going to use this formula right there. Okay, so it's going to be the square root of S times S minus A, S minus B, S minus C. Okay. Do an example, determine the area of a triangle of lengths 12, 15, and 9. First thing I need to do is to find out what that value of S is. S is equal to the sum of the sides divided by 2. If I do that, like right there, I get 18. Okay, so S is going to be 18. Now I'm simply going to plug that back into that formula there. Area is equal to S at times S minus A times S minus B times S minus C, and then take the square root of all that. If I simply plug in, I get an area is equal to 54. Okay? Hopefully that makes sense. A pretty straightforward formula. Here's some practice. I want you to read page 442. There's one example there I want you to look at. Here's some problems. A couple of these first couple problems have to do with Heron's formula. Just simple plug in and use it to find the area of a triangle. These four over here, these are word problems. Get you used to reading, drawing the diagram, and using either law of cosines, law of sines to solve. Okay? If you guys have any questions, make sure you're emailing me. Your problem set is due on Monday, so make sure you guys are getting started on that. And if you have, again, if you have any questions, just let me know. All right, fellas, have a good day.